Welcome to the Azure AD Architecture Deep Dive series. I am Carissa Coatmans, and I am a program manager on the Azure AD engineering team at Microsoft.
Hello, my name is Ramiro Calderon. I'm also a program manager in the Azure Active Directory engineering team.
We are part of the Customer Experience Program, and we help enterprises and business from all over the world to deploy our services and get to the cloud. We get a lot of questions about how Azure AD works under the hood, which we will share with you throughout this architecture series. In this first video, we're going to cover Password Hash Sync, or as you may hear us call it, PHS. So Ramiro, my first question is, why does Microsoft motivate its customers to enable PHS?
Well, there are a couple of important benefits of our customers when they enable Password Hash Sync. So why don't we walk through the flows and we'll discuss the benefits as we go through them. What do you think?
Let's do this.
All right, so the first thing to know is that Password Hash Sync has two scenarios. One is the actual synchronization of the password hashes, and the second part is how to use those hashes to authenticate. You can only turn on synchronization, and in fact, that's what a lot of our customers do when they are federated. They just do that at the beginning, and then they feel comfortable about it and eventually migrate. So let's talk about the synchronization today. The box here is the machine running on premises called Azure AD Connect. And one thing that is worth calling here is that Azure AD Connect is an umbrella of components that are installed. And one of them happens to be the synchronization engine. So let's go through the steps. The sync engine, the first thing it does is send a replication request using the same Active Directory replication protocol to the domain controller.
So the sync engine is like a domain controller. Should we protect it like a DC then?
Exactly. The way that we ask customers is to treat this infrastructure the same way as a domain controller. Now, for step 2, then the domain controller responds, and the replication payload with the changes of the passwords comes back in the original Active Directory encryption. So remember, this is the same protocol that domain controllers use to talk to each other. So that payload contained the passwords in MD4 format.
Ramiro, let's unpack a little bit what a hash is.
Sure. Hashing is a technique that scrambles a piece of data and generates another value of a fixed size. The idea is that hashing is one way. That means that the output can be used to derive the original value. And this is useful for password because the system stores a hash instead of a clear text password. And the users, when trying to authenticate, the computer applies the hash to the password as the user type it, and it can validate that's the same. So it's very cool. Now let's step 3. AD stores the password hashes using MD4, and that's a hashing function that has been around for a long time. The AD Connect agent rehashes this value with modern crypto. First, we take the 16-bit original value and we adjust it so it's 64 bytes. Then, the agent creates a random 10-byte salt for each AD hash and appends it to the original value. Salts make each value unique, even if two users have the exact same password, and that helps defending against attacks such as rainbow tables. Finally, we hash the resulting value using a more robust hashing function that's called Password Key Derivation Function 2, also known as PVKDAF2, and we used 1,000 iterations of HMAC SHA-256. All this process gives us a 32-byte value. In step 4, the Azure AD Connect engine sends data to the cloud. One thing that's worth noting here is that when we say Azure AD, there are a lot of backend components that enable different scenarios. Here, we happen to have this blue box that's the backend service that talks to Azure AD Connect. Now, the sync engine concatenates the 32-bit value that we just saw before, the per user salt and the number of iterations, and sends that new value over TLS to the backend service. Then, the Azure AD Connect backend saves the value it received in the core store over here in step number 5. The core store is designed to encrypt at rest the specific attribute that holds the credential. And on top of that, the machines here that run this core store component, they are also protected with this level encryption using BitLocker.
So the sync happens every 30 minutes by default. Does this mean that our customers have to wait 30 minutes for a password update?
That's a good clarification, Carissa. The entire flow runs every 2 minutes.
How does Password Hash Sync help us detect threats?
Well, once the customers enable PHS, we can detect leaked credentials, and here's how it works. When bad actors get a hold of legit username-password combinations, they usually share those credentials in the dark web, Pastebin, or similar sites. Microsoft monitors multiple sources to get a hold of those credentials, and this includes partnering with researchers, law enforcement, and other teams within Microsoft. So, when we get a feed with compromised credentials, the system looks up if there are matches in our customers by applying the same hashing that we discussed in step 3 to raw data. Unfortunately, We, as humans, tend to reuse the same passwords across multiple sites, so it is very likely that compromised passwords are also the passwords that are used in Azure AD. And if there are any matches, this means that the user is compromised. Azure AD generates a risk detection in the customer's tenant, so administrators can take action and correct. Moreover, customers using Azure AD identity protection can go further and automate the response by creating policies that indicate the users that they have to reset the passwords right away.
Got it. So this is what I'm taking away from my customers. Password Hash Sync can be thought of in two ways, as a synchronization method and a form of authentication. Customers can synchronize first and then decide later that they want to authenticate. This feature is great for all Active Directory customers, regardless of the type of authentication method that they are using, whether it's Federation, PHS, or PTA. And last, PHS adds a layer of security because it detects leaked credentials.
You got it.
We hope you found this video useful. We will be adding videos on different topics like authentication, provisioning, governance, and many more. If you want to get a copy of the diagrams we used today or want to give us feedback and help us figure out what to present in the future, please follow the link on the screen.